Hello, it's Duncan, and I'm back on the Gilded Rose today. I really enjoyed the Gilded Rose refactoring, but it was a refactoring, and I had a conversation with a friend Jack about what would happen if you just threw it all away really and started again. What would it look like? And he wanted to start from the specification and work out, but I thought, well, the specification as it is here, it's really quite complicated. You have to sort of delve into it. It's not really very understandable unless you have some of the code or some of the sort of context. So I wonder what would happen if we ran this as an XP project. And in an XP project, our customer tells stories about, so XP, Extreme Programming, our customer tells stories about the system, and we work on those stories. And we might negotiate over the sort of content of those stories to find a way through the system. And so what I started with really is the idea that we might have negotiated with a customer. There are a couple of things we could do very early on. One, we had the idea of stock, and so the story says adding items to stock. I need to add items to our stock. Every item has a name, sell by date and quality, and the quality is an integer that's always greater than 0. And that's our programming language, but we might have extracted that from talking to the customer. Quality can never go below 0. And the customer wants to see the stock list. So she says, I want to print a list of all the items in stock. And the print should show today's date and a list of all the items with their name, the number of days until the sell by, and their quality. Now, we know and our customer knows that there are then going to be things happening around the quality over time and different sorts of items and magic and so on. But what we're going to try and do is sit on all the rest of those stories and concentrate on just these ones and see where that takes us. Because in reality, systems, we don't know where they're going to go if they become successful. And so we want to implement the very minimum amount at every point, and then take the next story. And there was an XP practice which was called Sit on Your Cards. And it basically said, you may know the next thing that's coming up, but don't worry about that yet. Keep it behind you. Concentrate on today's task. So that's what we're going to do today. We have a couple of stories. So we're like a head one maybe as we do this one. And for clarity, we're not going to worry about persistence and databases and where these things live and so on. We may talk about that later, but effectively we're just going to run in memory. We're going to pretend that our computer remembers everything, and we're just really going to run with tests. So we're going to run with local variables in tests as our store of the state of the system. Also, we're saying that we are going to be doing test-driven development. So we are going to write tests, we're going to have failing tests, and as far as possible we're going to do what Keith Braithwaite, I think, called TDD as if you mean it. So we are actually going to write tests before we write production code, and only write production code when we have a failing test, and then refactor. That's really hard, to be honest with you. So call me out if we don't do that, but it'll be too late because it's a video. Okay, so armed with our requirements, we are going to do TDD, so we're going to do a test. And we don't really know much about anything at the moment, so we're going to create a thing and we're just going to call it tests. I'm going to add that, and later on obviously there will be more tests and different types of tests, but for now this is it. And I will split and move this right so you can always see the requirement over here. Okay. In order to go further, we need a failing test, which means we actually need a test. So we're going to say test fun test, which does nothing. We're going to get a passing test that way, I suppose, but let's get a passing test. Splendid. And now we have the first thing. So this is our sort of walking skeleton, if you like, at least the tests are concerned. We have this first story, adding items to stock. We need to add items to our stock. Every item has a name, sell by date and quality. Okay, so first thing item, second thing stock, first thing stock, second thing item. We know that there is this idea of an item. So let's say here is our stock, and it is an empty list of something, and what that thing is item. Now, we don't have an item. There are other items, it turns out, in the world, but we don't have an item for this. So I'm going to allow IntelliJ to create one. Doesn't seem to be one of the things it wants to do. Alt Enter, create class item. And it's going to ask where, and for now I'm going to say in this test. That would be fine. So let's say in this file. Okay, so now we have the idea of a stock. Everything's good. I need to add items to our stock. Every item has a name, sell by date, and quality. What do we need to do to bring that into existence? Well, I suppose we could say add items to stock. What does that mean? It means, well, we've got some sort of stock, and then we've got some sort of the stock with a new item, so I'll call that new stock. That's our stock, which is empty to start with, plus an item. And an item has a name. We'll go with banana, if I can spell it. A sell by date. How do I create sell by date? I don't know, but I feel that we have local date. I'd have to really, we have to think about dates because they always mess us around. I think local date will do here because we're actually a shop, physically a shop. But if we were an international concern, we might worry about which time zone our sell by date was in. Don't know. But for now, I'm going to go with this until it causes us problems, and I'm going to say we're going to go with local date now as a way of building a date. So its sell by date is today. That may be okay. And a quality. And 42 is a number, and it says here it's always an integer. So I'm going to, 42 will do. Okay. Now, this doesn't compile, so we have a failing test. I mean, we can't run the tests, and they're failing, but we can't run them. So, IntelliJ offering to add parameters to the constructor of item. Thank you, and we can name them at this point. So, let's do the simplest thing that could work, which is that this parameter name is name. The last parameter name is quality because I messed up the click, and this one is not now but sell by date. Refactor. Okay, that works. It passes, which is good, and so we now need a failing test to show that to do anything else, really, if we're going to keep this as simple as possible. What should we write? I mean, I feel that we could say that once we've done this, assert equals list of, and basically if we started with an empty list and we added an item, then the thing we should get back should be the same as a list of that item. We haven't created a assert equal, not that, goodness me, I don't know who comspun asserts is, but not for me, thank you. Assert equals. Pick the JUnit one. So we haven't created a class for stock. We don't seem to need one at the moment. A variable and a list of items would be fine. Okay, now that fails. Why has that failed? Well, because two items are not the same, despite the fact they're being populated the same way. And we know that we can solve this problem by making this a data class. And fixing all these the same way. Now we could write tests that show that two data classes, like banana and banana, aren't the same if they have different sell by dates or different qualities. There is an issue here over whether this banana is the same as another banana, that equality, and we might have to address that, because what does it mean to have two bananas that we both bought in. They both bought in at the same time. Yes, I don't know. But I mean, I do know, I suppose, that our list can contain 2 bananas. It's just we can't differentiate between them. That's okay for now, I think. So if we run this, that will get us passing. There is another little wrinkle here, which is this idea of the quality as an integer always greater than 0. We're not expressing that here because we could say -1. Now, how should we deal with that? We can either write a test that shows that we can't build an item with a quality that's -1, or we can fix it in our type system, and Kotlin has uint. I've never used uint. So I'm just going to go ahead and see whether or not that fixes our problems. I mean, obviously, it means that we can't compile code that does this. Whether or not that fixes all the issues we might have with quality, I don't know, but I'm going to suspend disbelief for now and give it a go. Okay, so far so good. I think that really expresses story 1. We might want to go a little bit further and say that that we show the thing that happens before we add. So that this is so stock is an empty list, and then when we added something happens to it. Not bad. I mean, we're really just leaning on the behavior of data classes and lists here, which is fine. So I might check that in, I think. And I might say this is add items to stock. Just before I do, probably we should take item, if this is production code, and move it into production code. So let's do that. Gilded rows main item. So now we have 2 of those. We have another file to worry about. But we're saying to our customer, hey, we've done this, so we should really get that into production in some sort of way. Okay, we're going to commit that. As always seems to happen for me, it's only when I have actually committed that I actually look at things and decide what if there's any real tidying up needs to do. We could rename this test, I suppose, but providing nobody really takes a look at this, I think it's good enough. And when I say nobody takes any looks at this, what I mean is if we had code review, if we had pull requests, somebody might be complaining about this not being as communicative as it should be, but we're going to make it better. And it is simple enough after all. We only have 2 tests, why should we? We only have 1 test, why should we have different names? Okay, so printing the stock list. We're about to have a second test, so this is add items to stock then. And we can use Kotlin's backticks to say add item to stock. So that allows us to differentiate between that and the next test, which is print stock list. Okay. We now go and read this story. I want to print the list of all items in stock. The print should show today's date and a list of all items with their name, number of days until sell by, and their quality. Okay, so the print should show today's date. Easiest thing to start with here always is to start with empty things. That'll give us make our lives a bit easier. So we're going to say print empty stock list is one test. What does an empty stock list look like? Well, we have one over here, so let's take that down here. And what does it mean to print? I think a printout is sort of a list of strings, really, isn't it? So I think we're going to say, what do we expect in this case? Our expected output. And if nothing else, we're going to have today's date. Today is the 29th of October 2021. And so if I take my stock and say I can assert equals expected, and I'm going to take my stock and I'm going to assume that I can ask it for a printout. I think maybe printout. Okay, so we can't run that because it won't compile. We could try. So to fix that, IntelliJ gives us the options of create an extension function, which will be fine. And we're going to make that on list, probably, could be other things. What's it going to return? It's going to return a list of string, because we said that was what printout means. And this is defined on list of E, but should be defined on list of item. And we can make our test pass by saying return list of, adjust the thing we expected. We're just going to fake it till we make it here. Does it pass? It doesn't, because we were only running that test before, so we'll say run all the tests in here. Don't know what is causing my fan to whir like that. Right. So now if we want any more functionality, we need another test. And so we'll take this test and make it into print non-empty stock list. How many items should be in a non-empty list? Well, one at least, I suppose. Let's put in 2, because that will give us some flexibility. So we need to build a list of items here, and we had banana here. So let's build some bananas and some kumquats. And maybe kumquat is a higher quality than banana, 101. Now, what should our expected look like here? Well, it's going to have the same header. And then over here, the print should show today's date and a list of all items with their name, number of days until sell by, and their quality. Okay, so a list of items. So we're going to have 2 more lines with their name. First one is going to be banana. We will arbitrarily use commas. We might speak to our customer about the exact format they want, but comma will do. They can always ask to change it. Number of days until sell by. Okay, so bananas, well, both these things we created with both these things we created with local date now, and so the amount of time between now and now is 0 days. So we'll just put 0 in for now and fix things up later. Make this a bit more stringent test later. But let's put the kumquat in, and at the moment, at least with the data we've got, that looks like that. So that's what we expect. Does it pass? No, it doesn't. Why doesn't it? Because we haven't printed out any items. How do we print out the items? Well, we've already got this unused list of items here we can make use of. So this, we can add this .map. And now we need a way of getting a printout for an item. So we might say it dot to printout, and again that doesn't exist, so we can say create either a member function or an extension function. Now my inclination here is extension functions, but we could make member functions methods. Let's go with this so everything stays in this one file for now. We can always move it. Okay, why does this not compile? Good question. it's because it doesn't know the type of this. So we know that the type of an item printout is going to be string. That compiles, but fails because we haven't implemented it. What should an item look like? We print it out. Well, we would return its name, so that's $name, the comma, number of days till sell by. Well, we don't know what that is, so I'm just going to say if we had a property which was days until sell by, we could put it in there, and the quality, and we do have that here. Now we need to get that compiling, and again we can create a member property here. So no, or we can create a extension property item days to sell by. There we are. Why it puts up there, who knows? Take it away, move it down here. And for now, we will get away with returning 0 in here as a string, because when we look at what we had in our spec here, our test here, we put in literal string. So obviously this can't live, but we don't have any reason to change it just yet. Okay, now let's make a reason to change it, and the reason to change it will be that we change the test. So what we might say is, oh, we want, let's show bananas being out of date, so that would be local date now minus days 1, and kumquat having a data run, so we could say add days or plus days 1. Now our expected then would be 1 and minus 1 for the bananas and 1 for the kumquat, and if we run that it will fail. So now we have reason to change our code, and what we want to do here is days to sell by. Okay, so we can't return 0. What we can return is the number of days between now and our sell by date. And I happen to have looked up that that is days dot between this dot sell by date and local date dot now. Import. Unfortunately, none of those other things we want to import. Well, Java time temporal chrono unit. I'm sorry you had to see that. Java time temporal chrono unit. There's simply no way to use the Java datetime without Stack Overflow. Small problem here that days between, we were saying it's returned string, it's now returning long, so long is fine. Let's see how we do. We've messed that up. So we had them the wrong way around here. So which have we got the wrong way around? Do we have the test the wrong way around or the code the wrong way around? Just make that go away. This is local date time minus days 1, so that is our sell by date is today minus a day, which is yesterday, so this would be out of date. So I think we've got this the wrong way around, and so this should be the days between now and the sell by date. Okay, that's nice. We can just tidy this bit up a bit by making expression body, and this by making expression body, and this by making expression body. Something like that. Now this is all very well until tomorrow, really, and at tomorrow then it will no longer be the 29th, then our test will fail. We can either find that out by checking in and waiting, but I'm not going to do that. We are going to fix it up now. How can we fix it up? Well, we could put today's date in here in some sort of way, but it would probably be better to ask for the stock printout on a particular day so that we can control that rather than changing our output. So what we're going to do is we're going to say this local date now I'm going to make a field out of in this test, and I'm going to call it now, but instead of instantiating local date time now, I'm going to say local date time pars, and I'm going to give it 2021 10 29. Now that doesn't change the fact that tests work, but it doesn't fix things either, really, because we're still asking the question local date now in here. So this will still only pass, but we've prepared it to pass another times. So what we're going to do now is we're going to take the thing that could change here, and what this thing that could change means is that this isn't a constant. It doesn't always answer the same. But this is a property at the moment, and we can't change. We can pass indexes to properties, but that feels a little naughty. So we're going to say, instead of making this a val, we're going to, I don't know quite where we have to do, click on this. We're going to say convert property to function. There we go. And that's not a great name, so we're going to call it days until sell by. We're going to remove the get, because get implies that it doesn't change over time, and it's about to, because we're going to push this thing out as a parameter. And we're going to say, we're going to call it now. Obviously it may or may not be now, but now is a good name for a thing that you often expect to be null. Sorry, expect to be now. And I said null, of course, because this question mark here, which is confusing things, we don't want to be able to cope with a null as the date. Okay, so I'm just going to drop that there, and now we've got the same problem with the printout. An item printout depends now explicitly on local date now. Make that a parameter, call it now in there. And again, it can't be null, so that will fix that. Okay, now our now and our now are in the same place, so we should be able to pull that out as a parameter to print out when you want to do it. Print out given some date, which we're going to call now. That can't be null, and that wants to be what's in here now. Whether or not the format works, we're about to find out. So we're going to say list of now dot toString, and we'll run that. Perhaps unsurprisingly it doesn't work because the date time format is wrong. So I'm just going to go and look up how to do that. Oh my goodness, that took a while. Who knows whether this is good or not, but we have format and we can now say format dot format now. Let's just see what we get. It works. Who knew? Wow. Okay, so this is our give it some better name, date format, make it private, and we're almost there. We're now just left with the fact that we pushed out all the way into printout local date now, but this will still fail tomorrow with when local date now isn't 29th of October, so we're going to go back with our constant here of now. And the same thing obviously true in here. Okay, we are running a little bit the raggedy edge of how long I want this test to be. So maybe before we check it in, we'll say this is really two tests. It is our item tests and our printing tests. So we'll just duplicate this and call it printing tests. Add that. What should there be in printing tests? Well, the printing test is what cares about the time. It doesn't care about adding item to stock, but it does care about printing an empty stock list and an empty stock list. And then all these things here are about printing. Again, we'd like those to be in production code somewhere. So I'm going to take them and put them over here, new Kotlin class, and I like phrases like printing for the names of files. So I'm going to call this printing. And I'm sure we could move them in a better way, but really the quickest, easiest way is to just copy, cut these out of here, put them in here, and make the thing that we care about, which is this, public. So now we have a bunch of private things, utilities that are making this work for us. Printing tests is fine. Tests, these are now effectively stock tests. And the stock tests don't care about now. Except they do care about. Oh, nice. Okay, so they do care about having some time for a sell by date, but sell by date of now isn't necessarily all that useful. So let's just inline those for now. For now. See what I did there? If we do all of them like that, that is so ugly it can't live. We'll just call this sell by to keep it out the way. That can go, that can go, and then all these are the ones that we moved. Get rid of them. Okay. Optimizer imports there. Quick little tidy up. Printing tests has some unused imports as well. Nice green tick from IntelliJ. This has a nice green tick. This was never ours. Okay, so at this point we have implemented, I think, obviously minus actually have an application and persistence and so on. We've implemented two stories: adding items to stock and printing a stock list. And we haven't cared about all the other things, about aging, about magical items and so on. We haven't looked at any of that stuff. We've just said what's the simplest thing that could work at the moment. And the simplest thing that could work is to have an item as a data class with these properties, and to have some way of printing just as functions, extension functions in this case, and that our stock is just a list of items, because we've nothing in our requirement that means that stock isn't just a list of items. Okay, we're going to commit that as item printing, and then we're going to have a chat with our customer about some more stories. Just before we do though, I think it's worth just having a look at our approach to time here. It would have been quite easy to end up with tests with a clock and mocking a clock, and we sidestepped all of that, and we sidestepped all of that here by passing a time around. So we have pure functions everywhere in this code at the moment. So our printing functions take a time rather than magicking one out of thin air, and because our printing functions take a time rather than magicking one out of thin air, then this code will always just work. Now, it may be a little bit inconvenient to have to pass the time into the printout, but really whatever code calls stock.printout can go and fetch a local date time now just as easily as the code inside stock printout. So our lives are made a lot simpler just by passing around times rather than extracting from anywhere, and there's not a single place now in this code where now is actually invoked, although in reality an app would at some point have to, in order to print the stock list, go and fetch the current time just before it did it. This has been coded as part of the Java to Kotlin series, and if you like this, I think you'll probably like Net Price and my book, which is called Java to Kotlin, a refactoring guidebook.